In the realm of contemporary science, one of today's most prominent and advanced physicists has shared his thoughts on a groundbreaking matter. Michio Kaku, a physicist renowned for his significant contributions to the fields of theoretical and experimental physics, has recently provided his expert opinion on the latest findings from the James Webb Space Telescope. Recognized globally for his outstanding achievements and scholarly work, Kaku's endorsement and analysis carry immense weight in the scientific community. According to Kaku, the James Webb Space Telescope has made a monumental discovery by identifying 6 massive galaxies that defy previous scientific understanding and expectations. These newly discovered galaxies challenge the existing paradigms of astrophysics and cosmology, suggesting that there may be unknown dimensions to our scientific comprehension of the universe. The implications of these findings are profound, as they could potentially revolutionize our understanding of the cosmos. This development is incredibly exciting and warrants close attention from both the scientific community and the public. Michio Kaku's willingness to discuss these discoveries openly underscores their significance. As a physicist of American and Japanese descent, Kaku is highly regarded for his expertise in both classical experimental physics and the complex theories of quantum mechanics. Unlike many conservative and skeptical scientists who often resist groundbreaking discoveries, Kaku is known for his open-mindedness and receptiveness to new scientific results, particularly those from cutting-edge missions like the James Webb Space Telescope. Kaku's enthusiasm for the results of the James Webb Space Telescope is palpable. He has expressed that the discovery of these 6 massive galaxies is one of the most intriguing highlights of his career, capturing his interest and imagination. His public acknowledgement of these findings adds a significant layer of credibility and excitement to the discussion. We invite you to join us in exploring the far-reaching implications of Michio Kaku's insights and the discovery of these 6 massive galaxies. Throughout his illustrious career, Michio Kaku has consistently demonstrated a willingness to entertain and evaluate new scientific theories. He recognizes that the established equations of relativity proposed by Einstein and the classical laws of Newton do not fully encapsulate the intricacies of the universe. This awareness positions Kaku as a forward-thinking scientist who understands that the recent discoveries made by the James Webb Space Telescope have the potential to significantly enhance the scientific field. However, he also acknowledges that many of his contemporaries in the scientific community are reluctant to adopt this progressive view, leading to a sense of unease and sleeplessness among proponents and opponents of quantum mechanics. The James Webb Space Telescope has provided a revelation by uncovering 6 massive galaxies that date back to the earliest epochs of the universe. These galaxies are remarkable not only for their size, but also for the fact that they contain more stars than our own Milky Way, despite having formed between 200 to 700 million years after the Big Bang. The team of astronomers responsible for this discovery has fittingly named these exceptional galaxies universe breakers, as their existence challenges and has the potential to revolutionize our entire understanding of the universe. This discovery suggests that something fundamental may be amiss with our current models of cosmic evolution. The Big Bang theory posits that the universe was in a state of chaos immediately following the initial explosion, with the first solid objects taking hundreds of thousands of years to form. It then took additional hundreds of millions of years for these objects to achieve sufficient density and produce light. The formation of complex structures such as galaxies was presumed to occur much later in the timeline. Yet, the newly discovered galaxies not only rival the Milky Way in size but also exhibit immense luminosity, indicating that they were forming hundreds of new stars each year, whereas our galaxy only forms stars sporadically. The precise timing of the formation of the first galaxies remains an unresolved question in astrophysics. Researchers have not yet determined the exact epoch of their emergence. It is understood that the initial cosmic structures may have been single stars or groups of stars that gradually coalesced into larger and larger formations, eventually developing into dwarf galaxies. These smaller galaxies would then encounter and merge with other galaxies, growing in size and complexity over time. Previous theories maintained that highly organized and massive galaxies could not have existed during the early universe, which raises profound questions about whether the universe is much older than previously thought or whether complex galactic structures formed much earlier than anticipated. This scenario presents a significant challenge to conventional scientific thought, particularly for those adhering to conservative models of the universe's evolution. Some branches of physics remain staunchly opposed to this discovery, questioning the validity of the age calculations and the implications for established cosmological theories. M. Kaku, however, embraces these findings and highlights the importance of experimental validation in the scientific process. He notes that many outdated and false theories have persisted over time due to the prestige of certain scientists, only to be discredited by crucial experiments that revealed their inaccuracies. In Kaku's view, the fundamental work of any science, especially physics, relies on the rigor of experimentalists who keep theoretical science grounded in empirical reality. Reflecting on our current understanding of the cosmos, Kaku acknowledges that we still know very little about the true beginnings of the universe. The Big Bang theory, established in 1927, was based on observations of the universe's expansion. These observations led to the conclusion that the cosmos originated from a single point and has been expanding ever since. At the time, this concept was difficult for both the public and scientists to grasp as it challenged the prevailing notion of an infinite, unchanging universe. Even today, scientists grapple with the complexities of a universe that has a defined beginning and is constantly evolving. These recent discoveries by the James Webb Space Telescope call into question long-held assumptions about the universe's age and the timeline of galaxy formation. Such findings necessitate a re-evaluation of existing theories and an openness to new ideas, a hallmark of the scientific process. The discovery of these 6 massive galaxies serves as a reminder that science is an ever-evolving field where new evidence can prompt significant shifts in our understanding. Historically, the idea of the Big Bang arose from the realization that galaxies are receding from each other, a phenomenon known as Hubble's law. This observation suggested that the universe is expanding. Supporting evidence for this theory came from elements such as cosmic background radiation and the redshift of light from distant galaxies and other cosmological structures. However, it is crucial to remember that past scientific beliefs, such as the geocentric model of the universe or the flat Earth theory, were eventually overturned by new evidence and technological advancements. Today, we may be witnessing a similar paradigm shift. Scientists had anticipated that the James Webb Space Telescope would confirm existing assumptions related to the Big Bang, but instead, it has revealed galaxies that appear to defy these expectations. This development underscores the necessity for scientists to remain open to new discoveries and to reconsider established theories in light of new evidence. One of the key tools in cosmology is redshift, which refers to the change in the wavelength of light as objects move relative to each other. This phenomenon is akin to the Doppler effect, where the sound of a moving car engine changes pitch as it approaches and then recedes from an observer. Similarly, when a light source moves toward us, its light shifts to bluer hues, and when it moves away, the light shifts to redder hues. By measuring redshift, physicists can determine the velocities and distances of celestial objects. However, small errors in these measurements can have significant consequences, prompting a review of the techniques previously used. As we contemplate the latest findings related to our cosmos, it is essential to consider whether they are genuinely based on redshift errors or if some scientists are simply reluctant to accept the facts. This question demands rigorous analysis and a careful review of the data and methodologies used in the research. In conclusion, the discoveries made by the James Webb Space Telescope have the potential to reshape our understanding of the universe. As M. Kaku and other scientists continue to analyze these findings, it is clear that science is a dynamic field, constantly evolving with new evidence and insights. Thank you for watching this video. We encourage you to share your thoughts and questions in the comments section. If you enjoyed this content, please like the video, share it with others, and subscribe to our channel for more updates on exciting scientific discoveries. Thank you for your support, and we look forward to seeing you in the next video.